Today, we continue our lecture with D, limits, infinite limit. Limit does not exist. Okay, so for D is infinite limit. So infinite limit ni, kita still consider function in terms of rational function. Okay, so kalau yang last class, kita dah masuk yang rational function tapi in terms of 0/0. Okay. Okay, so last class we have rational function. You ada 0/0. Sekejap okay. Oh, sorry. Okay, so last class we have rational function in terms of 0/0. So if 0/0, we have technique dia factor or rationalize. Okay, so for D infinite limits, dia in terms of fraction, but you have A/0. Okay, so kalau yang C 0/0, numerator 0, denominator also 0. For D, denominator only 0 lah. Okay, so numerator can be any numbers. For example, we have 1/0, or you have -3/0. So semua ni kita consider as limit does not exist. Okay, so for limit does not exist, we have three cases. Okay, we have case 1, case 2 and case 3. Okay, so nanti kita kena determine lah. So kalau soalan tu which cases. Okay, so for case 1, for if fx increases, okay, as x approaches a from the left. So when x approaches a from the left, a minus, so we have positive infinity. And when x approaches a plus, or x approaches a from right, so we have also positive infinity. So based on this graph, when x approaches from the left, so this graph is moving upward. So moving upward, lepas tu you have arrow at the graph ni. So maknanya graph tu dia akan continuous lagi lah. So dia continuous, that's why we assume dia as positive infinity. Okay, sebab graph tu continuous, you tak boleh determine limit at the y-axis. So kalau yang previous example, contoh yang awal tu, kita ada graph, contoh you have graph A, okay, so ni you punya function, okay. So ni yang example yang previous lecture, you have x and y. Okay, for example kalau ini you have 4 and then this one is 5. Okay, so kalau example ini, when you determine limit x approach to a minus dekat approach a from the left, you have answers dia is equal to 4. Okay, so kalau limit x approach to a plus fx dekat approach a from the right, so we have answers dia equal to 5. Okay, so kat sini kita boleh determine value at the y sebab graph tu terminate ataupun graph tu dia stop. Okay, so kalau graph stop, you automatic you boleh determine value at the y-axis 5 or you have value 4. Okay, tapi for D ni different dia. Kalau you tengok graph tu, contoh bawah ni, graph tu dia tak terminate, dia ada arrow, so graph tu akan always continuous, dia continuous upward. Okay, sebab tu kita sebab you tak tahu bila dia continuous, you tak boleh nak determine value at the y berapa. Okay, sebab tu kita assume dia as positive infinity. So positive infinity makna value tu akan increase je. Okay, value of y tu dia always increase. Okay, so ni example dia. So when limit x approach to 3 minus, so ni you punya graph, dia akan approach 3 from the left. So graph tu moving upwards until positive infinity. And when x approaches 3 from the right, okay, so the graph also moving upward. So we have positive infinity. Okay. Okay, so ni untuk case 1. Next for case 2. Case 2 is when x approaches a from the left, we have negative infinity. And when x approaches a from the right, also we have negative infinity. Okay, so example there, we have this function. Okay, so when x approaches 3 from the left, okay, so the graph is moving downward. Okay, so the graph have arrow at sini. Okay, so the moving downward also equal to negative infinity. Okay, so also when x approaches 3 from the right, okay, so the graph also moving downward. Okay, so also negative infinity. So negative infinity tu means that y dia, so this one is y. So value of y tu dia akan decrease. Okay, so that's why we have negative infinity. So kalau both sides negative infinity, so conclusion dia when x approach to 3, so yang ni for limit for two-sided lah. Two-sided when x approach to 3, also we have negative infinity, still does not exist. Okay. So for case 3, dia one side negative infinity. For example, when x approach to a from the left, we have negative infinity. And when x approaches a from the right, we have positive infinity. Okay, so ni example dia bagi function 3 over x. Okay, so when x approaches 0 from the left, so the graph is moving downward, so dia continuous. So we have negative infinity. Okay, so ini negative infinity. So when the graph approaches 0 from the right, okay, so the graph is moving upward, so we have positive infinity. So ini positive infinity. So conclusion, when x limit x approach to 0, so yang ni kita refer to two-sided dia, two-sided limit. Okay, you just state dia does not exist. Okay, so ini for case 3. Okay, so 3 situations can occur for rational function. So rational function, so ini in terms of a over 0. Okay, where limits do not exist. So first, they can be positive infinity. Okay, maknanya ni kita consider as both sides lah. Both sides dia positive infinity. Or kita ada negative infinity. Also kalau both sides dia positive negative infinity. Or we have positive infinity from one side and negative infinity from the other side. So ini refer to case 3. Okay. So untuk ini case 1, case 2 and case 3. Okay. So you can refer to example 11. Okay. So example 11, you have 1 over x minus 5 to the power of 2. Okay. So fraction, bila you nampak fraction, dia bukan semua you kata dia does not exist. Okay. So dia kalau case dia in terms of a over 0. Contoh you substitute value. So substitute value you dapat 1, substitute x dia with 5. So you have 5 minus 5 square. So you dapat 1 over 0. So kalau you dapat in terms of macam ni a over 0, atas dia numbers, bawah dia 0. So you boleh kategorikan dia into 3 cases. Either you boleh ada case 1, 2 or 3. Tapi dia all these three cases ni kita consider dia as does not exist. So semua does not exist. Cuma dia ada 3 kategori je. Okay. So you dapat 1 over 0. So you boleh proceed lah. You nak determine which cases tu. So you boleh buat table. So X. Lepas tu you ada Fx. Fx is 1 over X minus 5 to the power of 2. Okay. So center saya choose 5. Tapi sebab dia nak X approach to 5 minus. 5 minus means that X tu dia approaches 5 from the left. So kalau from the left, you kena choose value yang left from 5. Maknanya value yang less lah. Less than 5. Okay. So less than 5, biasa saya ambil 4.99. So dia less than 5 tapi still close to 5 lah. Okay. So for example, saya ambil 4.99. So you substitute X tu with 4.99. Okay. Lepas tu you tengok symbol je. Saya tak nak value. So saya nak symbol dia. Positif or negatif. Okay. So you dapat negatif lah. You dapat positif. Sorry. So you dapat positif. Okay. So you boleh conclude limit X approach to 5 minus. Function is 1 over X minus 5 square. So equal to positive infinity. Okay. So ini for A. Okay. So kalau yang B pun sama. First step dia saya substitute dulu value. So 1 plus 3 over with 3 minus 3. 3 plus 2. So you get 4 over 0. So kalau 4 over 0, maknanya you boleh determine lah cases dia mana satu. Okay. Dia semua in terms of A over 0. Okay. So bila 4 over 0, you nak determine cases tu, you boleh buat table. So Fx function is 1 plus X over X minus 3 and X plus 2. Okay. So kat sini we have X approach to 3. So dia tak state 3 minus or 3 plus. So kalau dia tak state maknanya dia consider yang ni as two-sided lah. So kalau two-sided maknanya you nak determine two-sided, you kena determine dulu yang one-sided je. Okay. So 3 kat center. First you kena choose yang when X approaches 3 from the left. Left value less than 3. So for example, I choose 2.99. So ini untuk 3 minus lah. Less than 3. For 3 plus, you choose value yang greater than 3. So for example, 3.01. So these two values ni, they're still close to 3. Okay, so you substitute 2.99 into function fx. So you get symbol dia negative. And then when you substitute 3.01, you have positive. Okay, so you write down limit x approach to 3 minus. So fx is equal to negative infinity. So negative ni comes from symbol ya, symbol negative. Okay. So when limit x approach to 3 plus, fx is equal to positive infinity. Okay. So baru you boleh buat conclusion. So you conclude for two-sided there, when x approach to 3, so fx is does not exist. Okay. Sebab dia nak soalan dia nak yang two-sided. Sebab tu last kali you kena conclude lah. Conclude yang two-sided limit. Okay. So ini for example 11.
Madam.
Ya.
Jadi kalau nak buat table tu, number tu ikut suka lah kan kita nak pilih.
Betul. Ikut suka asalkan dia tengoklah kalau yang 3 minus mesti less than 3. So you boleh choose any number yang less than 3. Kalau 3 plus, you choose yang greater than 3. Any number.
Okay, thank you madam.
Okay. So yang ini for example 11. Next for example 12. Okay. So example 12, you need to evaluate the limit. Okay, so first step macam biasa, you try substitute value to 5 over with 5 minus 5. So you dapat 10 over 0. Okay. So you buat table kalau dia in terms of Macam ni kalau contoh limit dia, limit x approach to 5 tapi function dia contoh to x minus x minus 4, x minus 3. Contoh x minus 3. So bila you substitute value, you dapat 5 over 5 minus 3. So you dapat negative 10 over 2. Kan? So kalau kat sini, you dapat negative 10 over 2 ataupun negative 5, dia denominator dia tak 0. So kalau denominator dia tak 0, so you tak perlu buat table. You table ni you buat bila you dapat denominator dia 0, atas dia numbers. Okay. So kat sini pun you dapat denominator dia 0, so atas dia in terms of numbers. So you proceed lah, you buat table. So you nak determine cases dia mana satu. Okay. So you have 2x over x minus 5. Okay. So center the 5. Lepas tu you choose less than 5. For example, 4.99. And greater than 5, 5.01. Okay. So substitute into fx. So you have negative and this one is positive. Okay. So limit x approach to 5 minus fx is equal to negative infinity. And when limit x approach to 5 plus, so fx is equal to positive infinity. Okay. So you conclude for two-sided, limit x approach to 5 to x over x minus 5 is equal to, does not exist. So does not exist. Okay. So your function ni kalau you nak state as fx pun boleh. Okay. So ini for infinite limit. Ada soalan tak for infinite limit? Boleh semua?
Boleh.
Boleh. Okay. Okay, so saya nak masuk limits of piecewise defined function. Okay. So for piecewise defined function, so ini you dah belajar last semester topic function. Okay. So piecewise defined function ni is combination of several function into one function. Okay. So for piecewise defined function, example je saya ambil yang A ni, you need to determine limit x approach to negative 1. So ini refer to two-sided. So kalau piecewise, before you calculate yang two-sided, you need to calculate first yang one-sided dulu. Okay. So you calculate limit x approach to negative 1 minus. Okay, so negative 1 minus, so you ada 3 function for example 13 ni. So you nak tengok function mana satu, so you kena refer to the range. Okay, so kalau negative 1 minus, you must choose function yang less than negative 1. So less than negative 1, refer to the first function. Sebab yang ini range dia for x tu less and equal to negative 1. So saya choose yang first function x plus 1. So after you choose function, next you boleh substitute value of x. Okay, substitute x with negative 1. So negative 1 plus 1 equal to 0. Okay, so next limit x approach to negative 1 plus. So negative 1 plus, you kena choose function for greater than negative 1. So function yang number 2. Sebab kalau you tengok range dia is x ni greater than negative 1. Okay, so saya choose the second function. Okay, next you substitute x with negative 1. So equal to 0. Okay. So baru you boleh conclude for two-sided. Limit x approach to negative 1. Fx also equal to 0. Okay. So ini for A. B pun sama lah. So B tu you kena determine dulu yang one-sided. 1 plus and 1 minus. So kalau function 1 plus, you choose function yang greater than 1. So function greater than 1 ni function fx dia equal to x. So ni function fx equal to x. Lepas tu for function yang less than 1, So 1 minus, you choose function less than 1, refer to yang inilah, less than 1. So you refer to the second function, 1 minus x square. Okay, so nanti substitute value, pasti you boleh determine. Okay, so itu for B. For B ni full solution ada pada recorded video. So you boleh tengok lah kat recorded video tu. So for C, limit x approach to 0, fx. So when x approach to 0, 0 ni position of x, dia dekat range yang number 2 ni. Sebab yang 2 tu dia between negative 1 and 1. Okay. So maknanya 0 tu dekat center dia. Okay. So that's why when x approach to 0, when you need to calculate 0 minus, you choose function yang inilah function number 2. Sebab 0 minus yang ini. So when 0 plus pun kat sini. Okay. So you choose function 1 minus x square. And for limit x approach to 0 plus, also you choose the same function. Okay. So nanti baru you boleh calculate yang two-sided ni. Macam ni you dapat 1, so this one pun 1. Okay. So limit x approach to 0, fx is equal to y. So ini for 0. Okay, so ini for piecewise defined function. Ada soalan tak for piecewise defined function? Ada Okay, so saya nak masuk. Okay, so limit at infinity. Okay, so limit at infinity. So the difference from previous our lecture tu, sebab you punya x tu dia approach to positive, negative infinity. Okay, so sebelum ni you punya x tu approach to example to 2. Contoh you need to calculate limit x approach to 2. Or you need to calculate limit x approach to negative 3. So ni yang sebelum ni. Okay, for f ni, x tu approach to positive or negative infinity. So maknanya x tu value dia akan increase or value of x tu decrease. Okay. So teknik dia, the end behavior of a polynomial matches the end behavior of its highest degree term. So you just consider highest degree term je. Okay. So you can refer example 14. Okay. So from A, so ini refer to polynomial ni baru kita masuk polynomial. Nanti for x approach to positive negativity ni, we have two types of function. We have polynomial and also rational function. Okay, so we go first for polynomial function. So for polynomial function, for example, highest degree term is 2x cubed. Okay, so you just substitute je lah. Substitute x with positive infinity. For A, limit x approach to positive infinity, highest degree term 2x cubed. So substitute x with positive infinity. Okay, so answer rate is positive infinity. Okay, so kalau B, highest degree term dia ini. Okay, so substitute with so ni sorry saya silap ni, suppose is negative infinity. So ini pun negative infinity. Okay, so substitute negative infinity to the power of 8 is still dapat positive. So positive and negative, so you dapat negative infinity. Okay, and for C, highest degree term is negative 3x to the power of 5. So you ambil sekali yang simbol negative, negative 3x to the power of 5. Okay, so x approach to positive infinity. So substitute x with positive infinity. So positive value power 5, still you dapat positive. So positive times negative, you akan dapat negative infinity. Okay, so ini for example 14. So semua ni consider as polynomial. Next for example 15, also polynomial. Okay, so you choose the highest degree term, negative 7x to the power of 5. So you solve limit x equal to negative infinity. So function is power 5. So So substitute negative 7, x dia negative infinity, power 5. So kalau negative to the power of 5, so value dia remain negative. So negative and negative, you akan dapat positive. Okay, so example 15 is positive infinity. Okay, so yang ini for polynomial function. Okay, next kita nak masuk limit at infinity, still limit at infinity, but different function. Okay, rational function. Okay, so rational function as x approach to positive, negative, infinity. Okay, rational function ni is fraction. Function to in terms of fraction. Okay, so you can refer to table, this table. Okay, so from this table, okay, so for example, x2 values dia increase. So we start with 10, next we move to 100 until last is 100,000. So x2 is increased. So as x increase, value for fx, so fx ni example they choose function 1 over x, function rational function. Okay, so function fx ni value dia start dengan 0.1 until 0.001 ni. Okay, so value for fx will approach to 0. Okay, so we can conclude as limit x approach to positive infinity. So x approach to positive infinity tu maksudnya x2 akan increase. X2 increase, so 1 over x will approach to 0. Okay, so from the second table, still we take example 1 over x for the function. Okay, but the values of x akan decrease. Okay, so values of x tu we start dengan negative 10, lepas tu we move to negative 100 until negative 100,000. Okay, so as x decrease, so value for fx, so fx ni function dia example we take 1 over x. Okay, so value for fx start dengan negative 0.1 until negative 0.0001. Okay, so the approach also to 0. So we can conclude as limit x approach to negative infinity, so negative infinity means that x2 decrease, so 1 over x will approach to 0. Okay, so yang ini dia bagi example function 1 over x, tapi dia still apply to another function. Contoh, kalau you ada limit x approach to infinity, function 2 over x, still kita consider dia equal to 0. Or you have function limit x approach to infinity, function dia negative 3 over x cube, so still juga 0. Okay, asalkan atas dia must be numbers, any numbers, and bawah dia must be variable. So semua kita consider as 0. Okay, ini untuk limit x approach to positive, negative, infinity. Okay, sama juga kalau negative infinity. So kalau kat sini x approach to negative infinity pun still 2 over x dah akan jadi 0. So if x approach to negative infinity, so the function negative 3 over x cube also answers the 0. Okay, so ini untuk limits of rational function. Okay, so teknik the end behavior of rational function matches the end behavior of the quotient of the highest degree term in the numerator. So sebab dia dalam bentuk rational function, fraction kan, so you have numerator and denominator. So you kena choose highest degree term in the numerator, divide with highest degree term in the denominator. Okay, so you can refer example 16. So example 16, saya nak tunjuk yang B je. So yang A tu you boleh refer recorded video. Okay, so yang B. Okay, so B when x approach to negative infinity, so yang ni in terms of fraction, so you choose yang highest degree term for numerator and for denominator. Okay, so equal to limit Okay, so you have 4x squared over with 2x cubed. Okay, so equal to limit x approach to negative infinity. Okay, so you simplify equal to 2 over x. So answer dia is 0. So dia 0 sebab based pada definition yang tadi lah, definition yang ini. So ini. Okay. So kalau dia approach to positive negative infinity, kalau function in term of fraction, atas dia numbers, bawah dia variable, so automatic you akan dapat 0. Okay, so that's why answers dia equal to 0. Okay, so ni for example 16. Okay, so for example 17. Okay, dia nak calculate limit as approach to infinity, function in terms of fraction. So you choose the highest degree for numerator, you have 5x, divide with x. Okay, so you simplify. So become 5. So based on constant rule, so kalau dia satu value je, so automatic function dia, a value dia you akan dapat equal to 5 lah. Okay, so kalau B, limit x approach to positive infinity, so highest degree term for numerator is 5x to the power of 3, and highest degree for denominator is negative 3x. So equal to limit x approach to positive infinity, so you have negative 5 over 3 x squared. So berapa answers dia? Berapa?
Negative infinity.
Negative infinity.
So reason dia sebab apa? You dapat negative infinity.
Sebab positive infinity square
Sebab
and
dia
then negative.
sebab you refer to yang polinomial kan? Sebab yang ini dia asal dia rational function, tapi after you simplify, you dapat polynomial function. So kalau polynomial function ni, you kena refer balik yang page 14 tu. So you know page 14 tu, dia ada yang limits of polynomial. Okay. So kalau polynomial maknanya you kena substitute je lah value dia. 5 over 3 x square dapat positive infinity square. So dapat negative infinity. Okay, so ini bukan code fraction sebab ni dah consider as polynomial. Dia different compared to example 16. Example 16 tadi, yang atas dia is a rational function. So after you simplify, you still dapat rational. So dapat 0. Okay. So ini for limit at infinity. Okay, so kita dah habis limit at infinity. Okay, so tak ada soalan Saya nak proceed.
Madam,
Ya.
yang rational function tu kalau denominator dia x square macam tu masih rational function
Betul. Kalau after you simplify ke?
Kalau dah simplify dia dapat contoh 1 over x square.
Betul, tu pun consider as rational. So kalau you dapat 1 over x square pun sama, you akan dapat answer dia nanti 0. Tapi kalau limit dia positif or negative infinity lah. So 1 over x square dapat 0.
Okay, thank you madam.
Okay, so ini for limit at infinity. Next saya nak masuk continuity at a point. Okay, so continuity ni sebenarnya dia dah masuk, dia pakai balik yang you belajar dulu lah. So kalau you tak ada problem yang sebelum ni, so saya rasa you boleh buatlah continuity ni. Okay. So for continuity, definition dia, a function f is said to be continuous at x is equal to c, provided the following conditions are satisfied. Okay, so for continuity, we have three conditions. First, FC is defined. Number two, limit x approach to C exists. And number three, limit x approach to C must be equal to value of the FC. So note there, when one or more conditions of this definition fail to hold, then we say F has a discontinuity at S equal to C. Okay, so continuity ni kalau based pada graph, graph tu maknanya dia hanya graph yang continuous. Kalau you nampak graph tu ada break ataupun dia putus, so automatic dia akan not continuous lah. Tapi itu kalau based pada graph. Okay. For example, figure 1.10 ni. So kalau you tengok, you have example dia bagi you 3 graph. Okay. So all these 3 graph, kalau you notice, graph ni dia putus ya. Tiga graph ni dia putus. So kalau yang A, dia break kat sini. Sebab you ada empty circle. So graph tak ada value kat sini. So maknanya dia consider macam dia putus lah. So ni pun sama, dia break kat sini. So ni pun dia break kat sini. Okay. So roughly you tengok graph ni sebenarnya you dah tahu dah dia semua tak continuous. Okay. Tapi untuk you punya solution tu, so you kena buat lah, you kena state balik condition dia. Okay. So from A, okay, so from this graph, you check dulu yang condition number 1. Condition number 1 state that FC must be defined. Okay. So kalau number graph A, FC dia, so FC ni makna exactly value X is equal to C. Okay, so kalau you tengok kat sini, when X equal to C, dia tak ada yang dense circle. So dia semua include empty circle. So kalau empty circle means that FC dia does not define lah. Sebab tu the state kat sini FC is not defined. So one condition dah tak satisfy, so automatic Fx is not continuous. Even limit dia exist. Okay, tapi sebab the condition 1 dah tak satisfy dah, so kita consider dia not continuous lah. So kalau B condition 1 dia you check for FC. So FC kat sini, FC dia define. So FC define since you have dense circle kat sini. So condition 1 dia dah satisfy. Limit, so limit dia does not exist ya. So dia tak satisfy condition number 2. So limit dia does not exist since when X approaches C from the left. So for example you have value dia L, tapi bila dia approaches C from the right, value dia is M. So the different values. So that's why limit dia does not exist. Okay, so still not continuous. And for graph C, okay, so kalau you check the first condition for FC, so FC is defined. Sebab you ada value dense circle kat sini. For example, value dia is M. So FCU is equal to M. Okay. Tapi kalau you refer to condition number 2, so condition number 2 for limit. So limit bila dia approach C from the left, for example you have L. So bila dia approaches C from the right, also you dapat L. So limit dia exist ya. So limit dia exist. So FC pun define, tapi condition dia number 3 dia tak satisfy. Sebab FC dia you dapat value M, tapi limit dia you dapat value L. So the different value. So dia tak satisfy condition number 3. Okay. So that's why Fx is not continuous. So ni example, all these three are not continuous. Okay. So you boleh refer to example 18. So determine whether the following functions are continuous. Ini saya ambil example yang A je. Yang B you boleh refer to recorded video. So for A ni example of a polynomial function. So you check dulu condition number 1. You substitute FC. So kat sini C dia is equal to 2. So substitute F2, saya dapat 2 power 4 minus 4 2 plus 4. So you have answers dia equal to 12. Okay, so condition number 1 dia satisfy lah. FC is defined. Okay, next you check condition number 2. So condition number 2 for limit. Okay, so limit you tak perlu calculate yang one-sided, you terus calculate yang two-sided je. So x approach to 2, so function, okay, so substitute x with 2 plus 4. So also equal to 12. So limit is exists. Okay, so satisfy condition number 2. Next, you check for condition number 3. So condition number 3 state that FC must define to the limit x approach to C. So kat sini, F2U is equal to the value of the limit. Limit x approach to 2 fx. Sebab both you dapat 12, so limit pun you dapat 12. So kalau value dia equal, so condition number 3 pun satisfied. So you boleh conclude fx is continuous at x is equal to 2. Okay. So yang B pun sama, nanti you akan dapat continuous juga. Okay, so you kena check all these 3 conditions. Okay. So ini example when the function in terms of polynomial. Polynomial senang sebab dia memang always continuous. Okay. So theorem, if the function f and g are continuous, for example, you have 2 continuous function f dengan g, so automatic the operation involve f and g also will be continuous lah. So f plus g continuous, f minus g continuous, fg and f over g also continuous. So continuity of a polynomial. Sini kita ada 2 je continuity, dia ada polynomial and rational function. So polynomial yang tadilah yang example 18 tadi. So example 18 tu polynomial. So polynomial is continuous everywhere. Maksudnya polynomial ni is always continuous lah. Okay. So polynomial memang tak ada problem, dia always continuous. So problem dia for rational function je. Rational function ni sebab dia in terms of fraction, dia ada certain function yang fraction dia continuous, tapi ada juga certain function yang not continuous. Okay, so tu theorem tu state a rational function is continuous at every point where the denominator is non-zero and has discontinuities at the point where the denominator is 0. So rational function ni sebab kita tahu dia fraction. So kalau fraction, dia akan jadi not continuous kalau denominator dia 0. Okay. So nanti dia akan jadi not continuous lah. So selagi denominator dia tak 0, so function tu akan continuous. Okay. So you can refer to example 19. Okay, you need to determine whether the following functions are continuous at x is equal to 3. So yang ni pun saya ambil example A je. B ni tu you boleh refer recorded video. Okay, so for A, okay, you nak determine function tu continuous. So you kena check lah 3 conditions tu. First, saya check condition 1. Okay, for FC. C dia is 3. So F3 substitute dalam function. So you have 0 over 0. Okay, so dia undefined. Okay. So kalau undefined, automatic condition 1 pun dia dah tak satisfy lah. Okay. So terus you boleh conclude fx is not continuous at x is equal to 3. Okay. So ini kalau continuity for function yang rational.
Madam,
Okay. So boleh. Yeah.
kalau kita dapat 0 over 0, kalau dia tanya continuous atau tak, kita dapat nak continuous kan.
Betul.
Tapi kalau sepatutnya dia boleh solve kan guna factorization tu.
Tu kalau untuk limit. So kalau limit, you nak calculate limit tu maknanya kalau condition tu lah. Kalau you nak calculate limit x approach to 3, baru you factorkan dia. X minus 3, x plus 3. So over x minus 3, so you cancel x minus 3. So you left x plus 3. So baru substitute value 3 plus 3, so dapat 6. So dia exist. Tapi untuk limit, so U factor tu hanya untuk limit. Bila 0/0, kalau you nak calculate limit, baru you factorkan dia. Macam condition number 1, dia bukan limit, dia hanya FC. So kalau FC ni, dia tak ada kaitan dengan limit, dia hanya value exactly x equal to 3. So you hanya masukkan dalam equation asal, original. So tak perlu modify equation tu. Okay, boleh? So kalau untuk A ni maknanya condition 1 dia tak satisfy sebab dia undefined. Tapi dia condition tu dia satisfy sebab limit dia still exist. Cuma dia tak continuous sebab dia tak satisfy condition 1. Boleh?
Boleh, madam.
Boleh. So you jangan confuse dengan limit. Limit yang 0/0 tu kalau nak calculate limit baru you kena pakai dua teknik tu. Factorization or you boleh pakai rationalization. Tu hanya untuk calculate limit. FC tu dia senang je. FC tu you hanya ambil original equation. So kalau function tak kisah function macam mana pun, you masuk je terus dalam function dia. Okay. So yang ni untuk yang example 19A. Okay, so nanti yang B tu, you boleh refer recorded video B tu, nanti answers dia. So B tu still not continuous ya. Macam yang B. Yang B ni you kena factor sebab B ni kalau untuk condition 1, F3. Kalau F3 sebab dia exactly x equal to 3, so you choose 4 lah. So dapat 4. Tapi condition number 2, limit x approach to 3, so you choose function yang atas ni. Atas ni untuk x yang not equal to 3. So you choose function x square minus 9 over x minus 3. Tapi kalau you substitute, you akan dapat 0/0. Yang ni sebab limit, then you kena factor lah. Limit x approach to 3. So you factor, you akan dapat x plus 3. Sama macam bawah ni. Okay. So bila you calculate, you akan dapat answers dia 6. Tapi bila, so dia satisfy condition 1 okay, condition 2 pun okay. Tapi dia tak satisfy condition number 3. Sebab condition number 3, value dia not equal. F3U, dia not equal to the value of the limit. X approach to 3 fx. Sebab F3 dia you dapat 4, tapi you punya limit you dapat 6. So kalau value dia not equal, condition 3 ni tak satisfy lah. Sebab tu yang B ni also not continuous. Sebab dia tak satisfy condition number 3. Okay. So yang ini for example 19. Okay, next for example 20. So example 20, sama juga you check condition number 1. So condition number 1 for F3. So F3 you ambil exactly x equal to 3, function ni lah. So dapat 6. Okay. So condition number 2, limit x approach to 3. So you choose function yang atas. Ni pun sama, you dapat 0/0, so you kena factor nanti. X minus 3, x plus 3, so over x minus 3. So you cancel, dapat x plus 3. So equal to 6. Okay, and last condition 3. So F3 value dia equal to limit x approach to 3 fx, hx. Sorry, ni function h. So ni you pakai h. H3 ni pun h. Okay. So dia satisfy condition number 3 sebab dia both dapat 6. So you conclude fx, hx is continuous. Okay. So boleh tak continuity? Soalan tak?
Boleh.
Okay. 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 So yang last ini. So ni you nak determine. You are given function. Lepas tu you nak determine mana point yang tak continuous. So biasanya point dia sebab kalau ada fraction, kalau based on theorem, you nak calculate point yang tak continuous bila denominator dia 0. Okay. So you, sebab tu you ambil denominator je. So you ambil denominator, you factor kan. So not equal to 0, so you dapat x dia equal to 3 and x equal to 2. So fx ni is discontinuous and x equal to 3 and x equal to 2. So maksudnya bila you substitute x equal to 3 dalam function ni, you akan dapat denominator dia 0. Sebab tu dia tak boleh x equal to 3 lah. Sama juga kalau you substitute kan, x is equal to 2 into this function. Okay, nanti denominator dia you akan dapat 0. Okay, sebab tu function ni, fx ni akan jadi not continuous at x is equal to 3 and x is equal to 2. Okay, so kita dah habis continuity. Okay, so 1.3 tu kita akan continue next week. So kita stop dulu kat sini. Okay, ada soalan tak?
Madam,
Hmm?
kalau dalam jalan kerja ni, kenapa dia not equal to 0? Kenapa kita tak buat equal to 0? Sebab memang ayat dia pun denominator is 0.
Dia boleh juga sebenarnya. Dia sebenarnya boleh juga kalau you nak kata dia equal to 0. Cuma kat sini kita tak nak ambil not equal to 0 sebab kita tak nak denominator dia 0 kan. So bila dapat x not equal to 0, satu lagi pun not equal to 0, tapi conclusion dia, you kena buat balik dah. Dia sebenarnya dia not continuous bila x equal to 3 dengan x equal to 2. So kalau you nak ambil, nak tukar kan, you nak ambil equal to 0 pun boleh juga. Nanti you akan terus dapat answers lah. You kata equal to 0 kan. So nanti you terus akan dapat x equal to 3 and x equal to 2. So dia pun boleh. Dia asalkan you faham maksud dia, dia tak boleh denominator dia 0 kan. So kalau you dah faham maksud dia, okey lah. Tak kisahlah simbol ni. Ni pun boleh, ni pun boleh. Okay, cuma kalau you buat not equal, you kena ingat lah final answer you kena tukar balik, jadikan dia equal. Asalkan final answer dia macam ni. Okay.
Okay, thank you madam.
Okay. Soalan lagi? Soalan? Okay, so nanti weekend ni, you ada cuti 3 hari kan? So you boleh buat lah. You buat exercise 1.1 until exercise 1.2. Okay, so that's all for today. Okay, so thank you semua.
Thank you, madam.
So kita jumpa nanti next week. Okay.
Thank you, madam.
Thank you,
Thank you, madam.
Thank you, madam.
Thank you, madam.
Okay.
Thank you, madam. Assalamualaikum.
Okay.